Do a couple examples where we're writing the recursive and explicit rules using our formulas for that. And the first one is just a simple 2, 6, 18. And what you want to check now is, could this actually be an arithmetic sequence, or is it a geometric sequence? So we would start by maybe subtracting successive terms to see if there's a common difference. And when we do 6 minus 2 or 18 minus 6, we get two different things, two different values. So it's definitely not arithmetic. So we would try the same thing with finding a common ratio. We can do 6 over 2 or 18 over 6. And this time we do get the same thing. We get a common ratio of 3. So now that I have the first term and I have a common ratio of 3, I can use the formula for the explicit rule of a geometric sequence. A sub n equals the first term times the r to the power of n minus 1. And we can write a recursive rule by defining the first term and defining the nth term by taking the previous term and multiplying it by 3. Okay, another example, 16, negative 8, 4, negative 2, and so on. And same thing, we would check if there's a common difference, maybe it's arithmetic, and we would check for a common ratio to see if it's in fact geometric. And once again, this one is geometric. Negative 8 over 16 is the same as 4 over negative 8, which is the same as negative 2 over 4. And so each time we do this ratio, we get the exact same value of negative 1/2. Now that we have the first term and the r, we can write an explicit rule to define the nth term as first term times r to the n minus 1, and a recursive rule by defining the first term as 16 and the nth term as taking the previous term and multiplying it by the common ratio r. This is just the repeated multiplication that turns into an exponential that we've talked about before. And last example, we've got a couple different terms in the sequence spread out. You know, they're not too far spread out, and they're not too far from the first term. So some people will kind of just play around with this and just try to figure out what works. But just imagine if you had terms way down the sequence and far, far apart from each other, that might be a little more difficult to do. So what I like to think of is how many steps we're taking. So to get from the third term to the sixth term, I'm going to multiply by r third to the fourth, to the fifth, and to the sixth. I'm going to multiply by r 3 times, which means I'm really working with r cubed. And then I also like to look at the ratio of the two actual term values, and I call this an overall ratio of the given two terms. And so if I actually divide 56 divided by 7, then I actually get 8. And so an overall ratio of 8 is basically what's happening as I move from the third term to the sixth term. I need to multiply by r 3 times to get a ratio of 8. So r cubed should be equivalent to 8. If I cube root both sides, then I get r of 2. So I still don't have the first term on this one, but I at least have the common ratio. So I can start writing an explicit rule, a sub n equals the first term times r to the n minus 1. Now I can substitute one of my terms in to help me figure out what the first term would be. So if I substitute a sub 3 equals 7, that basically means that n is 3 and a sub n is 7. A of that 3, or the third term, comes out to be 7. So I'm substituting 3 in place of n and 7 in place of a sub n. In other words, 3 goes in, 7 comes out. Okay, and so we can solve now for a1 and divide both sides by 4. 7 over 4 is a1. Now that I have r and I have a1, I can finally write my explicit rule. A sub n equals the first term times the r to the n minus 1 power. And again with recursive, we can define the first term as 7/4, and the nth term, we'll say multiply the previous term by 2, and that works. I'm going to skip just a little bit too. I know we just did 5, but I'm going to do number 7 because it stays along the lines with geometric. And this idea of kind of finding an overall ratio. So this says find 2 geometric means between 2 and 250. And the word means, it's a type of averaging, but you want 2 of them. So you want evenly spaced 2 followed by 2 more terms followed by 250. You can replace the word means with terms if you want to. Think of it that way. Find 2 geometric terms between 2 and 250. Okay, so same idea. If I know that it's geometric, I know there needs to be a common ratio. I can start by finding an overall ratio of 250 divided by 2. And so I've got an overall ratio of 150. Now I know that there's supposed to be 2 terms in between this. You can even think of it this way. 2 followed by 2 terms followed by 250. And this will help me think of how many r's I'm multiplying by to get from 2 to 250. So from 2 to the next term, I'm multiplying by r. From the second to the third, I'm multiplying by r. And from the third to the fourth, I'm multiplying by r. So I'm multiplying by r 3 times. So this 125, sorry. This 125 is actually equal to r cubed. And so now when I cube root, I get r equals 5. I thought the cube root of 150 might give us a little trouble. I mean, we could still work with that, but definitely 250 over 2 is 125. Sorry about that. So I've got an r value of 5, and this is not asking me to write an explicit rule. I actually don't even know if 2 is really the first term. There could be some terms prior to that. But by knowing that r is 5, I can now answer the question. I can find 2 geometric means, or 2 geometric terms between 2 and 250. So after 2, we would multiply by 5 again, multiply by 5 again, and it works. 10 and 50 are the 2 geometric means between 2 and 250. Okay, we're going to do something similar with arithmetic, and I did not do this on the arithmetic lesson yet, but it's a very similar process. We just have to make sure that we're thinking arithmetic and we're thinking of common difference. So 3 arithmetic means between 16 and 56. This is like saying 16 and then 3 terms and then 56. But this time I'm not multiplying by r, and I'm not going to think about a ratio. I'm going to think of an overall difference. So I'm going to subtract 56 minus 16. So I've got 40. This overall difference technically takes me 4 d's to get there. I'm adding d each time I move along an arithmetic mean, an arithmetic sequence. So every time I add d, it takes me to the next term. I'm adding d 4 times to get this overall difference of 40. So careful with the wording. 40 is equal to 4d, and we can now solve for d. As soon as we know d, we're not asked to write an explicit rule or anything like that again, so I can go ahead and fill in the blanks of my arithmetic sequence. We started with 16, and so I'm adding 10 each time, so 26, 36, 46, 56. It works perfectly. There are 3 terms evenly spaced between 16 and 56 in an arithmetic relationship, whereas the one we did prior was a geometric relationship. And that is it for this lesson. We'll work on the problems in class on Thursday. Have a good one.